Let us know about sixth class playing with magnets. All of you would have seen a pin holder in your school office. You may have seen that in this pin holder, some pins are attached to the cap. So here, like this pin holder ki pins అనేవి attach అయ్యి ఉంటాయి అన్నమాట. So why do the pins get attached to the cap of the pin holder? What could be there in that cap? Does it attract objects other than pins? Why are they? What are they? Magnets. You might have seen some metal stickers stuck to the door of the iron almirah or a refrigerator. What is there in those stickers which makes them stick to the iron doors? Do they stick to wooden doors or plastic doors too? Activity 1. Finding the objects that get stuck to the cap of the pin holder. Take a pin holder from your school office, drop some pins, jump clips, iron nails into it. What do you observe? Do you do the same with a piece of paper, a pencil, and an eraser? What do you observe? You would notice that pins, jump clips, nails get stuck to the top of the pin holder, while paper, pencil, eraser fall into the pin holder. Why does it happen? So the cap of the pinholder contains a special material which attracts the substance like iron pins, iron nails, etc. Similarly, the metal stickers also have a special material at the back, so that they can stick to iron doors. That special material is called a magnet. What material is needed for making magnets? However, these magnets discovered. Let us try to find answers to these questions. This is a new textbook finds totally. Right now, the neodymium is the strongest magnet currently known. Story of magnet. Around 5,500 years ago, there lived an old shepherd named Magnus. He used to take his goats and sheep to the hills for grazing. He always carried a wooden stick which had an iron cap on its lower end. One day, while his goats were grazing, Magnus dipped his stick into a spring of water and poked at the pebbles and stones at the bottom with it. Suddenly, he felt something pulling his stick. When he took it out of water, he saw a stone stuck to the iron cap. The stone which Magnus pulled out was called as a ladstone. Ladstone. It is a natural magnet and possesses the property of attracting iron. Around 2,500 years ago, there lived an old shepherd named Magnus. He used to take his goats and sheep to the hills for grazing. He always carried a wooden stick which had an iron cap on its lower end. One day, while his goats were grazing, Magnus dipped his stick into a spring of water and poked at the pebbles and a stone at the bottom with it. Suddenly, he felt something is pulling his stick. When he took it out of water, he saw a stone stuck to the iron cap. The stone which Magnus pulled out was called Ladstone. It is a natural the magnet and possesses the property of attracting iron. The magnets we discussed in pinholder and iron doors are not natural magnets. So the magnets are man-made magnets. Magnets of different shape. The magnets we see and use in our daily life possess different shapes. Some of the usual shapes of magnets are shown figure. This is a bar magnet like this, and here horseshoe magnet. Next, ring magnet, and next this one is a disc magnet and a bar magnet, horseshoe magnet, ring magnet, disc magnet. These are the some shapes of magnets. Almata. Can we make a magnet in whatever shape we desire? Think. Usually, special alloys of iron, nickel, copper, cobalt, and aluminium can be made into powerful magnets. Usually, special alloys of iron, nickel, copper, cobalt, and aluminium can be made into powerful magnets. Which materials are attracted by magnets? Take a bar magnet, nail, jump clip, plastic, scale, piece of glass, bar, keys, papers, iron bolt, pen, blade, pencil, knife, stainless steel, spoon, piece of papers, అంటే వుడెన్ ఐటమ్స్ అన్నీ కూడా ఇలా ఆబ్జెక్ట్స్ తీసుకొని ఇక్కడ నేమ్ ఆఫ్ ద ఆబ్జెక్ట్, మెటీరియల్ ఆఫ్ విచ్ ద ఆబ్జెక్ట్ ఈస్ మేడ్, ఐరన్, ప్లాస్టిక్, అల్యూమినియం, వుడ్, గ్లాస్ అండ్ అదర్ అని రాయాలన్నమాట. జంప్ క్లిప్ అనేది ఐరన్తో, స్కేల్ ప్లాస్టిక్తో ప్రిపేర్ అవుతూ ఉంటుంది. సో ఐరన్ ఆబ్జెక్ట్స్ కెన్ అట్రాక్టెడ్ బై ద మ్యాగ్నెట్స్. హియర్ టోటల్ కాన్సెప్ట్. The materials that are attracted by the magnets are called magnetic materials. The materials that are not attracted by magnets are called non-magnetic materials. Give your own examples for magnetic materials. Give your own examples for non-magnetic materials. Magnets have the property of attracting materials like iron. Based on this property of magnets, they can be used to separate some mixtures can be separate the iron fillings from soil. Take a bar magnet and roll it in the soil in your school ground for some time. Pull out the magnet. What do you find? Does anything get attached to the magnet? You may find some dark particles of soil sticking to the magnet. Now gently remove these dark particles from the magnet and collect them in the sheet of white paper. These are the iron fillings. Once a Greek scientist Archimedes used a ladstone to win enemies in battles by using ladstone to get the nails from the ship. The ship would sink. Once a Greek scientist Archimedes used ladstone to win enemies in battles by using ladstone to get the nails from the ship. So the ship would sink. Activity 4. Spread some iron fillings uniformly on a sheet of white paper. Place a bar magnet below this sheet and keep moving the bar magnet. What do you observe? Do you observe any change in the pattern of iron fillings spread over the sheet? You will observe that the uniformly spread iron fillings concentrated opposite at 2 points of the paper sheet. At some distance, you will find some scattered iron fillings between these 2 points. This change in the spread of iron fillings on the sheet of paper is due to the magnet present below it. The iron fillings move towards its ends because of this magnet. Thus, the ends of the bar magnet attract more iron fillings in the middle part of the magnet. By this activity, we can conclude that every bar magnet always has two ends whose attracting capacity is more than its other parts. These ends are called poles of the magnet. అంటే మనం గ్రౌండ్లో కలెక్ట్ చేసినటువంటి ఐరన్ ఫిల్లింగ్స్ వైట్ పేపర్ మీద పెట్టి కింద బార్ మ్యాగ్నెట్ పెట్టినప్పుడు ఎండ్స్ దగ్గరికి ఐరన్ ఫిల్లింగ్స్ అనేవి ఎక్కువ కాన్సన్ట్రేట్ అవుతాయి. ఎందుకంటే ఎండ్స్ దగ్గర అట్రాక్టింగ్ పవర్ అనేది మోర్గా ఉంటుంది మ్యాగ్నెట్స్కి అని మీనింగ్ అనమాట ఇక్కడ. Finding the directions with a bar magnet. Suspend a bar magnet freely with the help of a thread tied around its center as shown in the figure 4. Does the magnet remain stationary? Wait for some time. What do you observe? సో అంటే బార్ మ్యాగ్నెట్ తీసుకొని ఇట్లా ఒక స్టాండ్కి వేలాడేసినప్పుడు ఏమవుతుందంటే you will notice that magnet finally takes a position in the north-south direction and mark the end of these points towards the north. Now disturb the magnet and again wait for some time. Where does the colored portion come to the rest? Repeat this experiment in your classroom, playground and at your home. What do you observe? Magnets always comes rest in the north-south direction. In each case, the marked end point towards the north. This end is known as the north pole of the magnet. The other end which points towards the south is known as the south pole of the magnet. This property of magnets is called directional property. It is exhibited only by magnets. We use this property to make the magnetic compass. Magnetic compass. A compass is usually a small box with a glass covering it. A magnetized needle is pivoted inside the box in such a way that it can rotate freely. The compass also had a dial with the direction north S, south S, east E, west W marked on it. The compass is kept at the place where we wish to know the direction. In the needle indicated the north of the direction. When it comes to rest, the compass is then rotated until the north and south marked on the dial are exactly below the two ends of the needle. To identify the north pole of the magnetic needle, it usually pointed it in a different color. Then we identify north and south at that place. After that, we can also identify the east and west between them. This is a magnetic compass. A compass is used to find the directions. It is mostly used in ships, airplanes, mountaineers, and army people also carry a compass with them so that they do not lose their way in an unknown place. Don't place compass and magnets together. Activity 4, attraction and repulsion between two magnets. Take two similar magnets, place them in a four directions ways as shown in the figure. South, north, north, south. సౌత్ అంటే ఇక్కడ నార్త్ ఉన్నప్పుడు సేమ్ పోల్స్ ఉన్నప్పుడు రిపల్షన్ ఉంటుంది, ఆపోజిట్ పోల్స్ ఉన్నప్పుడు అట్రాక్ట్ అవుతుంది. సౌత్ నార్త్ ఉన్నా కూడా అట్రాక్ట్ అవుతాయి అన్నమాట. Some vets use magnets to retrieve wire and metal from animals. Some vets use magnets to retrieve wire and metals from animals. You will notice like poles north, south repel each other, and unlike poles north, south attract each other. Earth as a magnet. We saw that a suspended power magnet always comes to rest in north-south direction. Why does it come to rest in that particular direction only? What force is acting on it? Activity 7. Place a bar magnet on the table in any direction suspended. Another bar magnet over it. As shown in the figure 7, the suspended bar magnet should be fairly close to the one kept and the table. Observe it which direction the suspended bar magnet comes to rest. Change the direction of the bar magnet placed on the table. Do you find any change in the direction of the suspended bar magnet? Simple magnets are made using iron or steel. Next, in this case, the suspended bar magnet comes to rest in north-south direction. So we can say that there is some magnet below the suspended bar magnet which compared to it, they compel it to come to rest in that particular direction. Where does this invisible magnet come from? The earth possesses magnetic property which act upon the suspended bar magnet. North south. Make your own magnet. Take an iron nail and place it on the table. On the table, take a bar magnet and place the one of its pole near one edge of the nail. Without lifting the bar magnet, move it along the length of the iron nail till you reach the other end. Then lift the bar magnet. Bring it to the first end of the nail and move along the length again shown in the figure. Repeat this process 20 to 30 times. Always move the magnet in one direction. Don't drag the magnet back and forth. The compass was used hundreds of years ago by Chinese. Now remove the bar magnet and bring some iron fillings or alpins close to the nail. What do you notice? The iron fillings of or alpins are get attracted by the nail. Thus you have succeeded in making your own magnet by magnetizing the nail. What will happen in this nail? Is now suspended freely. Make your own magnetic compass. Take a magnetized needle. Tape the needle to a light cork. Float the cork in a glass of water as shown in the figure 10. Add a little detergent water to the help of the cork to float freely. In what direction does your magnetized needle point? If it points in north-south direction, then your magnetic compass is ready. Magnetic induction. Take the safety pin and bring it close to the alpin. Does it attract to the alpin? By bring the safety pin closer to one for the bar magnet and see how it gets attached to the magnet. Now bring an alpin to the and touch it to the safety pin as shown in the figure 1. Does safety pin attract the alpin? Why? So in the above two cases, we notice that the safety pin act as a magnet when it is in contact with another magnet. Magnetic property is induced in safety pin due to the bar magnet. If the safety pin is not in contact with the bar magnet, can it attract to all pin? What happen if we place the bar magnet very close to the safety pin but not touching it? Let us find out. Take a bar magnet in one hand and a safety pin in another hand. Hold them in such a way that they are close to each other but not in contact as shown in the figure. Ask your friend to bring an alpin and touch the safety pin. You will notice that the alpin will stick to the safety pin. This shows that due to the magnetic induction, safety pin is act as a magnet. Magnetic property is possessed by the bar magnetic substance. Due to presence of a magnet near it is called magnetic induction.